Hey guys, welcome to this last leg of the series of lectures that we are doing. So in this tutorial, we are going to do a quick post-processing of the results that we have got so far. So we are going to extract the qualitative results. So we're going to see colorful contours and streamlines to check the vertices and also about the velocity contours. Okay. So what we're going to do is that if you just scroll down under the component system, you can find results. So you can just drag and drop it and link with setup. I'm sorry, drag and drop it with solutions. Or the um, um, if you're using the fluid flow fluent, for example, if it is like this, you can just double click on results here. Um, Anything is okay. Okay. So if you're just going to double click here, so you just need to wait for a couple of seconds for CFD post to open up. This might uh, take a take some time. Okay. So if this kind of a information comes, please click request license and just wait for a couple of seconds until the geometry actually comes up into the post processing environment. There you go. So the geometry has been brought into the post-processing environment. So now what we're going to do is that first of all, we're going to see the velocity contours. So if we right click here on user plots, you can go to insert and say contour. And okay, you can give it as contour 1. And the location has to be the symmetry. Okay, so we want to see it on this plane, and the variable is not going to be pressure, but it's going to be velocity, and click apply. Now if you can see, the nice wake region at the back of the car. You can just zoom it in a bit here, and you can see the nice wake region. This is very similar to what the result is being shown here on sim scale also. So you can see here there is a nice wake region. So you can just go back to CFD post. This is how the wake region is going to look like. And if you want to just improve the quality of the contour, then probably you can just say 100 here in the number of contours and say okay. So here you can see now it is having a pretty smooth contour, and this is how you can play around to get any contour. So this is the velocity one. You can also choose to have a pressure contour. Say apply. So now if you can see, there is a huge static pressure at the start because this is where the first the streamline of air hits the vehicle. So it's quite intuitive that we will have a very high pressure region over there. So let me go back to velocity here in the variable and say apply. So now what we are interested in is to see this kind of a streamline. Okay, so these are called as streamlines. um, this will be useful for us to see these two counter rotating vertices. Let us see if you are getting that here. So again, to select here, right click on user location and plane plots and go to insert and click on streamline, say okay. So the type is not going to be 3D streamline, but it's going to be a surface streamline because it's going to be two-dimensional. So if I can go back here, then you can see that it is a 3D body, but you're just seeing the results on a two-dimensional plane. Okay, so that's the idea behind it. And now what I'm going to do is that the surface I'm going to select as symmetry. And okay, let's start by saying it as 25 points. Okay, so let's say apply. This might take a couple of seconds. And let us just turn this contours off so that we can see the streamlines better. We're not able to see much of streamlines because the number of points are too less. Maybe we can make it as 250 and let's try. So I'm just making it 250 and I'm running it. So I can see one vertex here. Okay, so this is very similar to the vertex that you can see here, right? So this is the kind of validation that you can do. You can increase the number of points. Maybe you can make it as 500, for example, and just see what happens. Yeah, now you can see this counter rotating vertex as well. Maybe you can make it 1000 again. Sorry, 1000. Say apply. So the more number of points that you increase, you get a very beautiful vertex that you can see here. Maybe now I can probably make it 1250. Just to check if there is another tiny vertex here. Yeah, there you go. So this result is very similar to the contour that you can see here. Okay, so let me just keep it side by side so that you can do a validation. So there you go. So the vertex structure is also very similar to what they have done on SimScale. So this stands as a validation to our work, because SimScale, as I was telling you earlier, is a very reputed organization. So their work has its own standards, right? So if you can see here, we have got a pretty good clean vertex. So these vertices, this wake region behind the car is the primary reason for the drag force and the drag coefficient, subsequent drag coefficient as well. So this is how you can check the coefficient of drag. And if you want to check the coefficient of lift, then if you remember in the previous tutorial, we went to forces and we said 1 0 for drag. Probably you can make it as 0 1, which is the lift force, so that is along the y-axis. So here if you can see, there is no negative lift, so the lift coefficient is about 0.304, which means the vehicle is not having enough downforce. So probably what we can do is, like, you can think about adding a wing towards the rear across the rear end of the car, so that we can probably increase the downforce. Essentially, the downforce coefficient or the lift coefficient has to be negative, um, because negative lift is what downforce is, intuitively, right? So the downforce coefficient has to be negative. Only then the vehicle will not lift off from the roads. So that is for another day, of course. But I hope you enjoyed this small lecture series, where you have been seeing how to model the Ahmed's body, and we have also gathered a very nice contour along with the counter-rotating vertices. Okay, so that is the end of this lecture series, and hope you enjoyed it, and it would have given you enough insight for you to go ahead with your aerodynamics related projects. So that's the end of the lecture, and thanks for watching the video.